Today's session is on ratio. I'm going to explain what a ratio is and how ratios are used in different situations. So to start off with, what is a ratio? Well, a ratio is a way of comparing amounts of ingredients. Ratios can be used to compare weights, money, length, and so on. So if we take this example, we've got a model boat whose length is 1 metre and the real boat whose length is 25 metres. Then we say the ratio of the length of the model boat to the real boat is 1 to 25. Notice we've just used the numbers without the unit, metres, and we've used the colon to represent the ratio. Ratios are used to describe quantities of ingredients in mixtures. For example, in the pharmaceutical trade, when you're making medicines, or in the building trade, when you are making cement or mortar, or at home when you're making up food. You use different quantities in different proportions, and if you don't get them right, then things go wrong. So it's very important to know what quantities you've got and in what ratio. So for example, if we have mortar for building brick walls, mortar is made up by mixing 2 parts of cement to 7 parts of gravel by volume. And we write that ratio as 2 to 7. Again, notice we've used the numbers without the units and the colon to represent the ratio. When we're making pastry at home, when we're making pies and tarts, we mix 4 ounces of flour with 2 ounces of margarine. And that ratio would be 4 to 2. But in this case, if you look at the numbers, they've got a factor of 2 in common. So we can simplify ratios just in the same way as we simplify fractions. We can divide by the common factor. So we divide 4 by 2 and 2 by 2 to give 1. So 2 to 1 is the simplest form of the ratio 4 to 2. But both of the ratios are equivalent because the relationship of the numbers involved stays the same. If we take this example, 250 to 150, we can simplify this ratio. We divide both by 10 to get 25 to 15. And then we can divide both by 5. 5 into 25 will give me 5. 5 into 15 will give me 3. We can't divide any more, so this is the simplest form. 5 to 3 is the simplest form of the ratio 250 to 150. But all 3 ratios are equivalent because the relationship of the numbers is exactly the same. In the same way, we can actually simplify this ratio, 1 to 1.5. In ratios, we like to have whole numbers. And in this ratio, you can see that we have a decimal. To get rid of the decimal, we can multiply both sides of the ratio by 10, and we still have an equivalent ratio. Because again, the relationship between the numbers is the same. So we multiply the 1 by 10, you get 10. Multiply 1.5 by 10, you get 15. 10 to 15, we can simplify that. Divide both sides by 5. 5 into 10 gives me 2. 5 into 15 will give me 3. 2 to 3 is the simplest form of the ratio 1 to 1.5. Similarly, when we have fractions, if we had this ratio, 1/4 to 5/8, it just doesn't look right. we want to express that ratio in terms of whole numbers in its simplest form. So what we do first is we write both as fractions over 8 in terms of eighths. A quarter is 2/8, and that the ratio is 2/8 to 5/8. And now it's dead simple. All we have to say is that is 2 to 5. We multiply both ratios by 8. And 2 to 5 is the simplest ratio for the ratio a quarter to 5/8. But again, all three ratios are equivalent because the relationship between the numbers is exactly the same. Moving on, we must have the numbers in the ratios having the same units. So if we had this ratio, 15 pence to £3, we cannot say that the ratio is 15 to 3 and then simplify that to 5 to 1 because we didn't start off with the numbers having the same units. The relationship between the numbers is not the same because, as I say, we didn't start off with these numbers having the same units. So we must convert the numbers to the same units and we choose whichever unit is appropriate. In this case, it's obvious we must change them to pence. So we say the ratio is 15 to 300, as there's 300 pence for £3. And then we simplify as normal. We divide both sides by 5. 5 into 15 is 3. 5 into 300 is 60. And then we can divide by 3. 3 into 3 is 1. 3 into 60 is 20. And notice these two ratios are not the same. They're vastly different. They're not equivalent because the relationship between the numbers is not the same. So it's very important in ratios that you start with numbers that have the same units. If they're not, then you convert them to the same units and then simplify if appropriate. As I said before, ratios are extremely useful in lots of different circumstances. They can be used to divide and share amounts of different quantities, like money, weights, and so on. So if I take this problem, just say I had an inheritance of £64,000 and it was to be shared between two people, Mrs. Sharp and Mr. West, in the ratio 5 to 3. What I want you to do is work out what each one of those gets. Now that's a lot of information to take in. So what I do first is I start off with a diagram. I've got the total inheritance of £64,000 and I divide it between Mrs. Sharp and Mr. West in the ratio 5 to 3. And we want to work out what each gets. What we do first is we work out the total number of parts that the inheritance is split up into. Well, we use the ratio for that. It's 5 parts for Mrs. Sharp and 3 parts for Mr. West. So altogether, that is 8 parts. Then we work out what the total value of one part of the inheritance would be. Now we know that the total inheritance is £64,000. So one part equals 64,000 divided by 8. And that is £8,000. And then the rest is easy. All we have to do now is take Mrs. Sharp, and she has 5 parts, and that is 5 multiplied by £8,000, which works out to be £40,000. And then Mr. West, he has 3 parts. And that is 3 multiplied by £8,000, which is £24,000. An awful lot of money. But what if I made a mistake? How can I check my 2 answers? How can I check that Mrs. Sharp did get £40,000 and Mr. West got £24,000? Well, a very simple check is to add up these 2 values, and if they add together to make up the total inheritance, then we think we've done our calculations properly. So a quick check, £40,000 plus 24,000 does equal £64,000. For a complete check, though, we can take the 2 amounts and see that they will actually make an equivalent ratio to the ratio that we started off with, 5:3. So if we take our 40,000 that Mrs. Sharp got, and then the 24,000 that Mr. West got, and cancel them down, we cancel by 1,000, then we cancel by 4, so that will make 10 to 6, and then cancel by 2, so that will make 5 to 3. We do actually get the same ratio that we started off with. We'll go on and do another example. This is an example which involves another mixture, making concrete. And with this, concrete is made by mixing gravel, sand and cement in the ratio 3 to 2 to 1. And in this problem, we start with concrete. The amount of concrete that we are going to make will be 12 cubic metres. And what I want to work out is how much gravel will be needed to make 12 cubic metres of concrete. So we start with drawing a diagram. And that represents the concrete. And we know we want to make 12 cubic metres of concrete. And we know it's mixed by mixing gravel, sand and cement in the ratio 3 to 2 to 1. And we want to work out the amount of concrete for 12 cubic metres. Well, first of all, we work out the total number of parts our concrete is divided up into, and we use our ratios for that. It's 3 plus 2 plus 1, and that equals 6 parts. Now our concrete is divided up into 6 parts. So 1 part must equal our 12 cubic metres divided by 6. So that's 12 divided by 6 cubic metres, which works out to be 2 cubic metres. Now we want to work out how much gravel is needed. Gravel is represented by 3 parts. So gravel, the amount that we want, equals 3 times 2 cubic metres, which is 6 cubic metres. And that's our answer. But it's always good to check. And so we try and do the calculation in a different way. And the way that I'd like to do it is using fractions. If we go back to the original diagram, we know that gravel is represented by 3 parts, and the total is 6. So gravel is a half of the total volume. And a half of 12 cubic metres is 6 cubic metres. So our answer is right. We've done a check. But what if we did a similar problem and we want to start off with mixing our concrete using gravel, sand and cement, but we don't know the final volume of the concrete. But we do know that we are given 6 cubic metres of sand and a limited supply of gravel and cement. How much concrete can we make then if we've got 6 cubic metres of sand? All right, we'll start the question or the problem with a diagram. We know that the mixture is still the same. We use the same ratio, gravel to sand to cement, as 3 to 2 to 1. And we know that we have 6 cubic metres of sand. But we want to work out how much concrete we can make with that amount of sand and a limited amount of the other two. Well, the number of parts that the concrete is divided up into is still 6. But we know that 2 parts is 6 cubic metres because that's what we're given. So 2 parts equals 6 cubic metres. So 1 part equals 6 divided by 2, which is 3 cubic metres. Now the total number of parts the concrete is divided up into is 6. So the amount of concrete that is produced is 6 times 3 cubic metres, and that is 18 cubic metres. Again, it's good to check our answer, and we'll do it in a different way, and we'll use fractions again this time. We look at what we were given. Sand is represented by 2 parts, and we know it has a volume of 6 cubic metres. Altogether, there are 6 parts for our concrete. So the fraction that represents sand is 2 over 6, which is a third. So a third of the total amount is 6 cubic metres. So the whole amount of concrete must be 3 times 6 cubic metres, which is 18 cubic metres. Here's another ratio problem involving ingredients. But this time, the ingredients are to make the Greek food hummus. It's usually given as a starter, and there are 4 ingredients. 2 cloves of garlic are combined with 4 ounces of chickpeas and 4 tablespoonfuls of olive oil. I sound a little bit like Delia Smith at this point. And the final secret ingredient is the 5 fluid ounces of tahini paste. Now, when you combine these ingredients together, that's enough for 6 people. But what if I want to make hummus for 9 people? What amounts do I have of these 4 ingredients to make it for 9 people? Well, we start off with what we've got and what we know. We've got 2 cloves of garlic with 4 ounces of chickpea, 4 tablespoonfuls of olive oil, and 5 fluid ounces of tahini paste. And that makes enough for 6 people. What I do next is that I work it out what each of those ingredients would be for 1 person. So I have to divide each of those numbers by 6. So that's 2 over 6, 4 over 6, 4 over 6, and 5 over 6. And then we cancel down, if we can. In this case we can. That's 1/3, cancel 4/6 to 2/3. And this will be the same. And the last one just remains the same, 5/6. And now it's dead easy to work out what amounts we need for 9 people. All we have to do is multiply by 9. So that's 1/3 multiplied by 9, 2/3 multiplied by 9, and another 2/3 multiplied by 9, and then 5/6 multiplied by 9. And we work out these calculations and simplify. 3 into 9 is 3. 3 into 9 is 3, and then 2 3s are 6. And this works out to be the same, which is 6, because it's the same calculation. 3 into 6 is 2. 3 into 9 is 3. 5 3s are 15 over 2, which works out to be 7.5. So our final answer for the ingredients is 3 cloves of garlic, 6 ounces of chickpeas, combined with 6 tablespoonfuls of olive oil, and 7.5 fluid ounces of tahini paste. And that will make enough hummus for 9 people. In a similar way, you can use this method in conversion problems. If we had the conversion that £1 is the same as 1.65 euros, and I wanted to work out what 50 euros would be in pence to the nearest pence. What I like doing first is to work out what €1 is in terms of pence. So I start with 1.65 euros equals 100 pence. €1 would then equal the 100 divided by the 1.65. And then to work out what the 50 euros would be, I multiply this by 50. That's 100 over 1.65 multiplied by 50. And that is 5,000 divided by the 1.65. Now, I am not going to do this by long division. I'll use my calculator. And I just type in the relevant numbers. 5,000 divided by 1.65 equals 3,030.30.30, repeating. So 50 euros equals 3,030 pence to the nearest pence, which is £30 and 30p. Well, that's the session finished now on ratio. But before I finish finally, what I'd like to do is just remind you of a few key points about ratio. First of all, what is a ratio? Well, a ratio is a way of comparing quantities of a similar type. When you write a ratio down, you use whole numbers separated by a colon. The numbers should be in the same units. If they're not, you convert them to the same units by using one or the other of the units involved. Just use your nouns, basically. And then you simplify as appropriate. In calculations involving ratio, it is useful to work out the total number of parts the quantity is divided up into, and then work out what one part represents.